Hi there. Now in my video today I'm going to continue the series that I've been developing over the last few weeks where I show you the processes that I go through to build out a new report. And I've chosen this COVID case fatality rate information. This is something that I'm passionate about. I think there's not enough information available from the government, and therefore I'm trying to build my own reports so that I can understand what's truly going on. I've had a lot of really good and positive feedback from people saying they've really enjoyed the way that I've shared my thought processes, and so I'm going to do the same again today. I'm not going to do a lot of prep. I'm just going to jump into this particular review and show you the thought processes that I go through to solve a particular problem. Just an update on the data. So the data hasn't come in yet for the 30th of July, but currently 92.3% of all active cases of COVID in Australia are not sick enough to go to hospital, and 2.7% of the total available capacity of the ICU in New South Wales, which is where the outbreak is currently being taken up by COVID patients. So here's the data. Now, this report is a little bit different to the one I've used previously. I actually decided to switch out of the world data into some Australian data. It just means that I get a response a little bit sooner than I otherwise would, because the daily data comes in more frequently. And I've also been able to access some more detailed data around death rates and those sorts of things. So I'm not going to go back and show you the complete rebuild. I mean, you can follow the principles that I followed in the previous videos. Just having a look at this death lag slicer again, you'll see here that if I go back to zero lag, you'll see that the cases coming in always precedes the deaths, so the deaths take some time. When I first started this journey, my view was this particular phase, the Delta variant with the current vaccination rate, was 10 times less fatal, as shown up here. This is the most fatal phase we had here, this one here. And my initial view before I started to analyze the data was that this phase, what I'm calling phase 4 in Australia, was 10 times less deadly. But once I looked at the data, once I had a proper visualization, and once I changed my visualization and improved it, and I brought in this lag slider, I was actually able to align the lag in deaths against the actual cases. And so you can see with this green line now that I'm only considering the active cases up until this green line, which is basically the point in which the lag in deaths come in. And as a result of that, we're currently showing 2.9 times less fatal than the worst outbreak we had in Australia, which was about a year ago. So just really important to understand the data. Okay, let me jump over to the deaths detail, and I want to show you the topic of today's session. So this is my Twitter post from this morning. This is one of the worst visualizations I've seen. I found this on a Twitter feed. I just think it's a terrible visualization. If you take a look at it, there are two different colors on this column chart. When I first saw it, it was unclear to me why there was two different colors on a column chart. And normally you would use two different colors to indicate either good or bad, or maybe something different about those two particular groups or legends, if you like. But in this case, it's the same axis, so the colors are matching to the data on the axis. I couldn't also work out why the deaths in 60 to 69s was so high compared with the 70 to 79s. And it was only after I literally spent a couple of minutes understanding that this age group 70 to 70 plus has been plotted on the right axis with fatality rates up to the early 30s, whereas the black column chart has been plotted on the left axis with fatality rates around the 0 to 1% rate. And so this is just a terrible way to visualize data. A column chart is not designed to visualize data this way. You should not be putting items of different scales on a chart like this, even if you're using colors to differentiate the difference. So I thought, well, let me go and see whether I can come up with a better way of visualizing this data using my COVID report. And so I'm going to jump over to my deaths detail page, and I'm going to import the image. So just bring that into the chart. Now, this is a little unfortunate quirk of Power BI, is that when you import a visual, it doesn't lock the aspect ratio. And so this is really annoying. Have had an idea to get that fixed for some time. What I normally do is immediately come in and resize it so that the aspect ratio is good, and then basically lock the ratio from there, and then you can resize it pretty much as you need. All right, so this is the death detail that I've got coming from the local data that I've got access to. You can see the deaths back here about a year ago. I do already have the age groups of these deaths, and I also have the data coming in. There is actually an error in this data. I thought I'd fixed it. If I jump in, I might see if I can fix this particular data error. I have alerted the people that are the source of this data that there's an error there. I thought I put an override into my report, but I'll have a look at that perhaps when I get going as well. Okay, so now let me start off by completing the data set that I've got. So I have age brackets already. These are 10-year age brackets, and I've got the death details, and I've got my calendar table. I've got a few other tables here. So I don't have the population data for Australia at the moment. So that's the next thing I need to do, because if I'm going to come up with a chart that shows the percentage fatality rate, I need to know the total population for Australia. And in fact, I think I should also load the total population for New South Wales, because even though these are Australian death rates, they're actually probably more correctly New South Wales death rates, because that's where the current outbreak is. So the next thing I need to do is find some data. And I just did some research before starting this video. So it actually is quite difficult to find data in some cases. And I did a little bit of research, and I have found this particular page from the Australian Bureau of Statistics. Previously, I've located some of this age data, and so a great tip is that once you find a page that's useful, just copy that URL, and I've got a Word document that I've now keeping to keep track of these good web pages when I find them. So this is population data. So once you find some good links or good resources to data, it's a great idea just to create a document that you can save these links. It's going to save you a stack of time later on. So I'll just save that for later use. All right, so here's the web page. Now on this web page, down the bottom, I found Australian demographic statistics tables. And if I click on this link, it will download the Excel file. So let me just do this again. I click on this link. It downloads the file, and then if I open the file, now this is a pretty typical file that's available from the Australian Bureau of Statistics, and notice that there's many tables, many pages here. And if I come down this table 7, population by age and sex, shows promise. If I click on table 7, I've got data. In fact, it's already got the percentage of population. Not that I would use that in my particular reports, but say 2019, I think that's up to date enough. I note that the age groups are a little bit different to the ones that I'm using. And also I note I don't have by state here. So that may be an issue that I need to look into. So let me jump back and see if I can find one that has population by state. So age and sex, states and territories. Let's have a look at number 5. All right, so now we've got by state. This one doesn't have the age cohorts. Let's have a look at number 6. All right, so now I've got by state. So this is just for 2019. So this is the one I want. Table number 6, it's got the breakdown by age. It's got the states along the top, and this is what I want to load. Now, I could go ahead and connect Power Query directly to that file that I downloaded. But if you recall from one of my earlier videos, what I wanted to be able to do was to have this report be able to refresh online on the service without having to download the file. And so wherever possible, I want to try and connect to a live online data source so that I don't have to install a gateway and I don't have to use OneDrive or anything like that. So let me go back to this report and grab my Excel file, and what I'm going to do is I'm going to right click and open this in a new window. Notice the URL. It still seems to download the file, but I'm just going to give this a go. I'm going to copy the URL, Control C. I'm going to come back and I'll say get data from web, paste the URL, and let's just see what happens. We've got nothing to lose. If it works, it works. If it doesn't work, we're no worse off. If it does work, I potentially have a live connection without needing manual intervention. Not that the population data changes that often, but I think it's still good practice. All right, so this is looking promising. The website is coming up. Let's expand the web page. Okay, so this is good. This actually looks like it's the Excel file. You can see embedded in the URL there is the Excel file. And so I've already done an analysis of the file. So best to download the file, find what you want. Now I know exactly what I want. I want table 5. And let's go about transforming this data and loading it up. Now, one thing that I learned last week when I was doing a similar demo is that if the query automatically generates a web.browser contents, then it will not automatically refresh when you publish it to powerbi.com. You must have a gateway installed if you're using web.browser contents. I didn't know that before. I had to go and ask Miguel Lopez at Microsoft for clarification. He explained it to me. So be really careful when you're connecting to something on the web. If it's web contents, it will work. If it's web.browser contents, then it will not automatically refresh without a gateway. In this case, it looks fine. So the current steps are navigation. I'm going to delete this change type. And now let me step through the process of doing some transformation. So the same as I've done before, what I would normally do, I'll give this a better name. So this is the Australian population staging table. I do like this technique that I learned from Ken Pools. I'll turn that off. I'll put it into my staging tables. Now I've got a nice, clean, direct link to the raw data. Now I'm going to transform it. So I'll right click and reference. Give this a name. So this will be the Australian, I'll just call it population because in the case of this particular report, it's Australia anyway. And I'll go about through the cleansing process. There's a problem. So I actually think I've loaded the wrong table. I've got the data here by year. I wanted the data by age group. Just let me go back to my Excel file. Here's the data by, okay, table 6. So this is so easy to do. We all make mistakes. So let me come back. I need to now start swimming upstream. So this population table connects to the source. Of course, the source is this one here, connects to this one here. And if I look here, you can see that the navigation step is table 5. So this is an easy fix. I just have to change that to table 6. And that's automatically added the change type step again. So let me get rid of that. And now I've got the correct data and that automatically flows through. So this is warts and all building reports. This is the way it happens in reality. So don't feel bad if this happens to you. Okay, so let's go about transforming this data. So row 5 is my header. So remove top rows 4. Now I need to use my first row as header. So I've got the states, the change type automatically kicked in. I might just delete that. I'll come back and add that myself later. Okay, so these age groups now notice that these age groups are different to what I have in my model. Now, I'm not quite sure what I'll do here. I'm not a big believer in destroying detail unless I have to, because at some stage I might choose to come back and look at a lower level of granular detail. So my preference would be to keep this level of detail. So I might have a think about that as I progress. All right, now I've got a problem here because the males and females, so the sex of each of these cohorts is not in a very good location. So I really need this, I need the sex to appear in a new column down the page. And so this is a pretty easy fix. What I would normally do, just have a quick inspection of the data. Notice that there's a null in this New South Wales column, and notice here that I've got some nulls at the bottom. So just get rid of those first. So remove the bottom rows 3. And I also might just do a little bit of tidying up. I'll get rid of this all ages because these are the totals. I don't need those all ages. So let's get rid of that. Just cleaning it up a little bit before I do the next transformation. All right, so notice that I've got in this New South Wales column, anywhere there's this piece of information that tells me is it males, females, or all the population, there's a null in this column. And so I'm going to use that to my advantage. I'm going to add a column. It'll be a custom column. And I'm going to check for the existence of a null here. So it's a simple if New South Wales equals null, lowercase. The IntelliSense is not great here, just be careful. So if New South Wales equals null, then I want the age group years. Else, I just want null. So let's go OK. I just called it custom. And notice now that I've got this males, females, and persons out in a column of its own. And also notice that I have nulls beneath it. This is very important. And so now I can click on that column and I can go transform, fill down. And now I have my column that tells me which sex each of these data points is. And now I can filter out the persons, just keeping the males and females. I really hate capitalization, so I might just do a format, capitalize each word. I prefer that. Let me do some more cleaning up. I'll get rid of this column. I think what I'll do, I'm going to move this to the beginning. So let's go move to the beginning, and I'll give this a name. I'll call it gender. And instead of removing this column 11, what I'll do is I'm going to highlight the columns that I want to keep and remove the other columns. I think generally speaking, this is a better practice because if a new column appears in a future update of the file, this way that extra column won't find its way into my data. So I've highlighted the columns I want to keep, right click, remove other columns. And so now now notice that this gender has appeared back at the end. Now, I'll tell you why this happened. This used to really drive me crazy, but let me just go back and show you exactly what's happened here. I moved the gender column to the front. Then what I did is I came back here and I clicked on the Australian Capital Territory, scrolled left, shift clicked on gender, and then I right click and removed other columns. And when I did that, notice that the gender appears back on the right. Now this is actually working as designed. The way Power Query works is that the order in which you select the columns is the order in which the data will be returned. And so this is an easy fix. Just let me show you one more time. I'll delete that step and I'll come back and click the gender column first, scroll to the left, shift click on the last column I want to keep, right click, remove other columns. And when I do that, I have the gender in the location that I want. So that really confused me for a long period of time until I worked out what was going on. All right, so let's do some more cleaning. I need to get rid of these totals. So get rid of females and males. This just leaves me with the cohort data now by gender and age group in years. I've still got text here, but that's okay. So I'm going to keep these first two columns, right click, and now I'll unpivot the other columns. The attribute and value is state and population. You can come in here, double click and rename these columns. There's nothing wrong with doing that, but I like to learn how the language works. Notice that this unpivot other columns seems to have a hard-coded name for those two columns. I'm just going to change the hard-coded name. I'll call this state and I'll call this population. And then I will just change the data type on this one to whole number. This will actually work if you've got commas in your numbers. It will actually detect that and do the conversion just fine. All right, so that's the data, but I really want to handle this age group issue. So let me go over here and have a look at what I've got already. So I've got my age groups in tens, and I also added this age sort column because I needed to be able to get the group that's 100 to sort correctly. So I just basically hard-coded a solution here to give me 99, and now that sorts in the correct order. All right, now just thinking about this problem a little bit. This is a dimension table, and the first column is the primary key of the dimension table. If I take my new data, which is the population data, just let me move it up into the data model. If I take this new data and load the data at the age group level that I have here, it's going to change the level of granularity. If I change my dimension table to that level of granularity, I'm going to cause a problem with the current join that I'm using. So what I'm going to do, I think, is to use a bridging table. So let me do this a little bit ad hoc. I'm going to right click and reference this. This is going to be a throwaway query. So I'll reference that. I'll remove other columns, remove duplicates. So this gives me the current bands, and now I need to map these bands against the age groups that I already have in my dimension table inside a bridging table. So I don't know if this is going to work. I'm going to copy that table. This will be interesting. Enter data. Let's just see whether I can paste this table in here. I didn't know whether that would work, but the reason I've done this is that I want to manually manipulate the data. I mean, I could write a conditional column that did this, but I actually think just typing it in manually is going to be just as fast. In fact, it's probably even better if I do it in Excel. So let me just jump over to Excel and I'll paste the data here because it's actually going to be a lot quicker if I do the work over here. So just let me go back and check my existing table. So I'll just cancel out of that. So my ages, I actually don't have 0 to 10, so 0s, 10s. I need to perhaps go back and fix that as well. So they all start with the decade followed by an S. So the reason I'm doing it in Excel is it's just faster, right? So I can do 2 rows at a time. So 0S, Control Enter, and then this will be 10S, Control Enter, 20S, Control Enter. I'll just fast forward over the rest of this. Okay, so that's all of those. I'll call this band 10, and I'll call this band 5. All right, so now that I've done that manually, I can just cut and paste it, Control C, and I'll come back here and I'll do enter data and just cut and paste it. Now, the reason I'm doing this is that I want this to be a standalone report. I don't want to have any links to Excel files. And so rather than managing a master Excel file of master data, I'm just going to cut and paste it here so that it's totally encapsulated. So this is going to be my bridging table. I'll call it my age bridge. And I'll click OK, and I'll show you what I'm going to do with that in a moment. So now that I've done that, I can delete this one. That was a throwaway table, so I can just delete that. I do have to address this missing data. So I'm missing my 0s and my 10s. And so in order to do that, I'm going to need to go back and have a look at the source. This comes from death details. And if I come back to death details and go to the source, this is actually coming from the online source. So clearly there's been no one that's died in their 0s or 10s, and therefore my dimension table doesn't contain that data. But now with my new dimension table, with the total population, I need that missing data. So this actually brings me into another interesting concept, and that is, how do I add data? Now, there's a few different ways of doing this, but what I'm going to do is I'm going to do a new query. I'm going to create a blank query, and I'm just literally going to generate the data that I need. Okay, unfortunately I can't see I'll just go =1 because I don't want to lose that query. So I really need to see this. So this is something that I quite often do. So I'll come in, I've got a little screen capture. So it'd just be great to have a picture of this that I can refer to. I would typically put this on another screen. I'm just going to do that. You obviously won't be able to see that, but at least I can see it on the other screen. Okay, so I want to generate the missing data. And so, look, there's various ways of doing that, but I'm going to create a list of lists. So this is the list operator. So 1, 2, if I do that, it generates a list like that. And I can generate a list of lists by saying something like this, 3, 4. And if I do that, turn that into a list of lists, so double brackets, then this first list has 1, 2, this second list has 3, 4. And so what I'm going to do is I'm going to create a list like this, age bracket, case sensitive, exactly the same as my existing ages table. So age bracket and then age sort with no spaces. So that'll be my first list. There are other ways of doing this. I just prefer list of lists. The second one needs to say zeros, zeros. So it'll be like this. And just to speed things up, the next one will say tens, tens. So header, first row, second row. And the next thing is to turn this list of lists into a table. Now you might think that I should be clicking this to table button, but that's not going to solve the problem. I actually need to get a 2-column table. And so there is a special piece of M code that I need to use here. So I'm going to add a custom step. I'm going to manually add a bracket first because the IntelliSense is a little bit flaky. And the function is called, I want to create a table dot from rows. So this will generate a new table from my existing list of lists. And you can see I've now got a 2-column table with those rows, and then I can use the first row as header. And now I have the new data that I need. This is going to be my, I'll just call it missing age brackets. And I'm going to turn off the load, move it to my staging table down here, and then I can append that data here. So I can just come up, append query, take what I've already got, and I'm going to append the missing age brackets. And if I sort that now, I don't need to sort it, of course, before loading, but it'll just to validate that I've got it correct. You can see that that's correct. In fact, I should have sorted on the age sort column. All right, now, one more thing. So think ahead. What would happen if at some point in time, someone in Australia does die between 0 and 10 or 10 and 20? Then I'm going to be appending a new row to this column, plus the original source data is going to generate that row as well. It's a dimension table, and therefore it's going to cause the query to fail. So the last thing I'll do, I don't need that sorted row. In fact, I don't need this one. I'll just get rid of that as well. So the last thing I'm going to do is I'm going to click on the primary key, which is the age bracket, right click and remove duplicates. Even though there are no duplicates in this column now, by doing this now, it will prevent a potential issue occurring in the future should some young person unfortunately die from COVID. Okay, so now I've got the tables that I need. What I need to do is come back to this population data and change the granularity. Now, I've just realized that I called this a bridging table, but I actually don't need a bridging table. What I need is a mapping table. So let me just go and fix that. So this is the mapping table. And what I need to do is I need to remap the population data. So basically I want to roll these groups up to that higher level of aggregation without throwing away the detail. And so I'm just going to do a merge. So I'll click on this, I'll do a merge query. I'm going to merge the population data with the mapping data. The merge is here, left outer join, then I can extract the band 10, and now I've got my band 10 as well as my age group. I might just rename this to band 5 just so it makes a little bit more sense to me. So look, there's different ways of doing this. I could have loaded it as a bridging table and completed that join inside the model, but I think it actually makes more sense in this case just to have that band 10 there, and I'm going to keep the band 5 data. So with that, I'm going to close and apply. And so after that's refreshed, here is my new population table. I've got both the band 5 and the band 10, and so I need to join these using band 10. And so now I've got my new table of data loaded. Okay, so let's go over and have a look at some visualization here. So whenever I do this, I just like to start with a matrix. I'm going to bring in my age bracket into my matrix, and I need this death data. So I'm going to bring in the detailed death count. And so these are the numbers. Now I've actually got a slicer here which is impacting this visual, and in this case that's exactly what I need because I'm just wanting to look at this particular phase. So these are the phases that I set up before. So this phase starts on the 1st of June, and if I jump back at this death detail, the death started in July, and because I'm looking at percentage death rates, I don't really need to go back to the entire phase. So I think the month data in this case is fine. All right, so here's my detailed death count by age group, and so now I need to bring in the new data, which is the population. So I perhaps will just do a quick implicit measure to start with, just to do a quick visual inspection. The age bracket data needs to sort. So my 0 is not correct. So I need to get this hundreds in. I'm not quite sure why that's not working. Maybe something went wrong when I reloaded that data. Just let me try and resort that. Okay, so that's better. I'm not quite sure what happened there. All right, so here's my population data. I can see that that looks approximately correct. This is one of the reasons I don't like to use implicit measures, is it's very hard to see the numbers. So let me just go ahead and write a new measure. So this will be total population. Technically it's population in 2019, but that's okay. Sum of the population. Do the formatting. Just put 1000 separator, and we'll chuck that in and have a look. All right, so there's the population and the death count, and once you're visualizing the data like this, it's pretty easy to see what we need to do, and that is just to divide one by the other. So I'll write that one. Now this is another little IntelliSense bug. When the name of your measure in part is included in the table name and the measure name, the IntelliSense incorrectly puts the table name in front. And so it's very annoying. I reported that bug about 3 years ago, still hasn't been fixed. So divide detailed death count by the total population. And then let's have a look at that. We'll just quickly do some formatting. So percentage, I don't like 2 decimal places, 1 is plenty. And just for quick visual confirmation, I'll put that in, and let's have a look. All right, so these are, they're very small numbers, of course, but this is the point. All right, so now I did mention that maybe it would be better, instead of looking at Australia, is just to look at New South Wales, because this particular outbreak is in New South Wales only. The population of New South Wales is about 1/3 of that of Australia. So I think the next thing I'll do is I'll just come and put a filter on this one visual. So I'll expand that, get my population state, add it to the visual, and I'll just bring in New South Wales. Still not enough to make this work, so I'm going to have to increase my decimal places. So in this case, these numbers are so small that it's just, it's nonsensical to present the data this way. So this is something that you always have to think about when looking at data. So instead of doing the percentage case fatality rate by age, in fact, it's not percentage case fatality rate, it's percentage death rate by age. Case fatality rate takes into account how many cases we had. So sorry about that. So percentage death rate by age. So this is not an appropriate number in this case because it's such a small number. So I think what I might do is I'll do death rate per, let's do say per 100, I'll just try per 100K to start with. So we need to divide the death count by the population and then multiply it by 100,000. Let's see what that does. I need to, now it's no longer a percentage, so I need to go back, change this to general, and I really want something that displays and renders properly with one decimal place. So I think that data is a lot better. I wonder if I did it per million. Just let's have a look at if that data is easier to read. I think that's better. I think that highlights the data better. So let's call this death rate per million population and age. It's not age, it's age group. Good name for your measure is really important because it helps you understand what's going on. So let me click on that. Much better visualization. I can now take the population out. In fact, I can take the death count out as well. And now I've got the raw data that I need. Now, obviously, there are some age brackets here with no deaths. So what I'm going to do, I want to visualize everything. So remember, this is all about showing the truth, all the information, not just part of the information. So I'm going to come up to this age bracket. I'll set it to show items with no data. And in fact, in this case, it's blank. And so I actually want to see 0. So I'm going to come up. The easiest way I know is just to add 0 to the formula. So by default, if the answer is blank, it will turn blank. If you add 0, it will turn it into a number. So let's just do that. And in fact, because I've added 0, I really don't even need to turn on this feature. And so just by adding 0 forces all of the data cohorts to be displayed. All right, so let me turn this now into a column chart. Notice I did the work using a matrix. It was only once I got the numbers right that I decided to turn it into a column chart. Okay, so I probably should improve the title of this visual. So I can just override that manually. So this is death rate per 1 million population in New South Wales. I don't think I need to say by age group and age bracket. I think that's obvious. Now, I haven't actually done a lot of work here. It is possible that one of these deaths did come from another state, but just intuitively, I don't believe that's the case. Now, the objective of this video was to try and demonstrate a better way to visualize this. Now, as it turns out, I would just leave it exactly like it is now because it's clearly communicates the situation as far as I'm concerned. But notice that these are very small numbers, and these two black and this aqua color on two different scales. So I wonder what would happen if I looked at the total data instead of looking just at July. So I'm going to come up and turn off the interaction. So I don't want this slicer to impact this visual. I think this is better for this particular purpose, and so therefore I might just change this title again. So I'm just going to change it just so that it's clear that this particular chart does not react to this slicer. In fact, this slicer is only just to be able to drill down on a lower set of data, and so it's probably a good idea just to put some sort of visual confirmation about that. This is a trick that I use quite often. So I'll come down and I'll just turn off the fill. I'll leave the outline on, bump that up a little bit so it's bold, and I will also send it to the back. So I'll move that shape right to the bottom so that it doesn't hover in front, and it won't get in the way when I try to click on the slicer. So sometimes just putting a visual indicator like that can make it clear that this slicer that I have here is actually only related to this one visual, even though it's on the same page. There's a few other tricks I can do to improve the way that works, but I think I'll just leave that for this exercise. Okay, so I've now got this showing the entire pandemic, and now you can see the problem, which has been solved in a way that I didn't think was particularly well up here. And so the next question is, how do I go about visualizing this a little bit better than is shown on the screen at the moment? Well, the truth is that there is no one correct way to do this, but what I observe by looking at my data is that anything less than 70 is basically immaterial. I mean, all I'm really getting from this is that I'm getting some information to tell me that there's at least one death in each of these cohorts. I can't really see the number, and really the other piece of information that's been communicated is anything that's less than 70 is virtually immaterial. So what I'm going to try is just to group these 60s and below into one data bar so that you can see the total size of everyone from 0 to 60 compared with the other population cohorts, and then perhaps try and break out a separate bar chart for the 0 to 60s. And I'm not really sure what this is going to look like, to be honest, but I'm just going to duplicate that. Let me come in here and just filter away the larger numbers. It's interesting, I've got I'm not quite sure what's happened here. Oh, I see what's happened here. So as I duplicated that visual, the visual filtering, as I duplicated that visual, the edit interactions didn't become inherited. So I need to go and fix that. So edit interactions, this slicer does not impact this. Okay, that's better. Strange behavior. All right, so I'll come here and let me just get rid of the other cohorts, 70, 80, wrong one, so clear that. I just want to keep the low numbers. And so notice how much clearer this is for the 0 to 60s. I'm missing the 20s, so better add that in. All right, so this is giving me much more detail. So this chart here is basically doing what this chart here does, and in a way this chart here is doing what this chart here is. But the top one, of course, is masquerading two different sets of data in the one chart. That's the problem with that chart. All right, so just to make this more complete, I think what I'll do is I'll bundle anyone from 0 to 60 into one data bar on this top chart. Now, there's a few ways I could do this. I could do it as a calculated column inside my age table, but that feels a bit dirty to me because I prefer to do all of my data manipulation in the one place. So I'm going to come in and edit the query. and I'll do a conditional column inside this table instead. Okay, so what I'm going to do is I'm going to duplicate this column. So right click, duplicate. And then I'm going to do a replace values. And I'm going to basically get rid of the S. Replace values with nothing. I've now got a numeric column, which I'm going to turn to a number. And I might just rename this, I'll just call it age. And now I just invested a little bit of time in doing this first because it'll make my conditional column so much easier to write. And so now I can add a column, conditional column, and my new column, if the age is greater than or equal to 70, then I actually want to use the age bracket itself. Otherwise, I'm going to create a new cohort which will be less than 70, as it turns out. So let's give it a name. This will be I'll call it roll up, for the lack of a better name. Okay, so now what I'm going to do before I move on, I'm not quite sure if this is going to sort the way that I need it to sort. So I'll just do a quick little test. I'll just sort it and see what happens. Okay, this is so definitely not what I need. So I need another column as a sort column. So let's just duplicate it. Once I've done that, I'm going to do a couple of simple transformations. Place less than 70 with 60. That'll do. The numbers actually don't matter as long as they're in ascending order. And I might just replace the S. Now I can convert this to a whole number. And I'll just do a quick sort on that, make sure it's working. So less than 70, 70s, 80s, 90s, 100s. Okay, so now that I've done that, I don't need this sort here. That was just there for testing, but I do need the duplications and those other steps. And I should call this sort roll up. And I should change this to text. Okay, so now I've got my roll up banding that I want to use for that other chart. So I'll just close and apply, and let's go ahead and use that. So remember, the objective is to take the detail out of this top chart and then use this bottom chart to explode the detail. Not quite sure how I'm going to visualize that just yet, but let's go ahead and okay, so I'm going to remove the age bracket. I'm going to bring my roll up in. So I'll change the sort by column to sort roll up. But so let's go back and change the sort orders. All right, so there we have it. We've got our chart now that's showing clearly that anything under 70 is just, it's almost irrelevant for this particular data set. But now what I want to be able to do is I'm trying to visually indicate that this particular bar here, if I want to see the detail, I can do so by looking at this particular chart down the bottom. I'm going to put a few shadows on this. A lot of people don't like shadows. I just think it's one easy way to make your Power BI reports pop a little bit better. And I'm just going to try a good old drawing. So I'll insert a shape. I'll just take an arrow and maybe I'll bring that down here. And I might rename this chart So I think that's communicating. I wonder whether I can perhaps in this case. So remember I said up here I didn't like the fact that there were two different colors. It was confusing. I didn't understand why. But I think what I might try and do is see if I can change the color. And so by turning on that, I'm going to change the color perhaps to something not too aggressive, being red, but maybe a green color, nothing too scary. So there's a green color, and then I'm going to do the same thing here. Same green color, and then I'm going to do the same thing here. And this time the entire chart will be that green color. So, so look, this is one way of making it visually clear what's going on here. So the top chart is showing me death rate per million population for the entire pandemic across age groups. I've got a different colored green bar for the less than 70s, and then I've got a visual indicator showing that there's a second chart here that breaks out the detail. Now, I don't know about you, but to me, that's a lot clearer what's going on. I have two charts. Both charts are in a completely different scale, completely different order of magnitude. I've used color to indicate there's something different about this one data point, but instead of putting the difference on the same chart, I've actually broken that out into a new chart with a completely different scale. There's no misunderstanding that the bottom chart is somehow related to the scale of the top chart. That is definitely what's happening with the image at the top. But I don't know, that's the way I went about solving the problem. I'd be interested to hear in the comments below what you would do to help call out the information, the level of detail that we need in this particular case. Okay, so a bit of time has passed and I've done a bit of cleaning up of this report, just tidied things up a little bit. I've added some chart labels so that it's clearer to see the number. And the more I look at this, the more uncomfortable I am about the message that this is communicating. Now, remember the original objective was to demonstrate the principle of how better to communicate two charts that are on vastly different scales, particularly as you go down the x-axis. So the x-axis got so small that it was not meaningful. And what I've decided after looking at this data is it's really just not the best choice of data. I don't have the details of the age of the people that caught the virus, and therefore I'm not able to work out the same case fatality rate as the sample data that I showed you earlier on. And I tried to do a deaths per 1 million population. The reason I did that was because the percentages were so small that it was irrelevant. But as it turns out, saying that 2,300 people out of every million people, over 100 have died, is not really that relevant either, because the numbers are just sort of so out of whack. And so what I decided to do was I just had a bit of an exploration. I duplicated the report and I decided to change the report so that it shows the total deaths by age group, just to give me some opportunity to demonstrate this principle, the objective up front, which was to show you how to handle it when some of the data down the lower end of the axis is so small. And so I think this is much more meaningful now. So never be frightened to change the way you're communicating your data. If you build a report and it's not telling the story, then maybe it's the wrong report. Do something different. And so now what we can see is I've got this 923 total deaths in Australia over 18 months. You can see just 12 of them were in their hundreds. That makes a lot more sense now. You can see the bump here. So most of the people are in the 80s. Just out of interest, the life expectancy in Australia, orders of magnitude, is about 83 or 84, something like that. And then it drops off rapidly after that. After the 70s, there's only 58 people under 70 that have died over the last 18 months with COVID. And if you look at the breakdown of that 58, you can see the second chart, which is on a much different axis. And I think that's just a better way to communicate the data.